China has just made a discovery on the moon that has sent shockwaves through the scientific community and left the United States scrambling to catch up. In the 20th century, the race to the moon defined the geopolitical rivalry between the United States and the Soviet Union. But now, decades after those first footsteps on the lunar surface, a new contender has emerged with capabilities that rival and in some ways surpass those of the original space race pioneers. The story begins with China's methodical approach to lunar exploration over the past 2 decades. While other nations scaled back their space ambitions, China doubled down. The Chang'e program, named after the mythical moon goddess from Chinese folklore, has been the centerpiece of this effort. In 2019, the Chang'e 4 spacecraft became the first to successfully land on the far side of the moon, something no country had done before. The success of Chang'e 4 was followed by Chang'e 5 in 2020, which marked the first sample return in more than 4 decades. Now, with Chang'e 6, China has taken another giant step forward. In June 2024, Chang'e 6 landed in the South Pole Aitken Basin, the moon's largest and deepest impact structure, located on the lunar far side, and returned 1,935.3 grams of lunar material, including soil and rocks, to Earth, marking the first time any mission has retrieved samples from the moon's far side. Analysis of these samples, conducted by teams under the Chinese Academy of Sciences, among others, have revealed that the far side is far more geologically complex than previously thought. The Chang'e 6 mission deployed advanced robotic technology and cutting-edge instruments designed to analyze the lunar surface with unprecedented precision. Buried beneath the surface of the South Pole, Chinese researchers discovered evidence of a previously unknown mineral composition. This mineral, given the temporary name Changesite, appears to have unusual features that could change how scientists view the formation of planets and the development of the moon. In addition to this potential new mineral, the mission also recorded unexpected patterns in the moon's magnetic field. These patterns point to the possibility that the moon once had a more active geological past than scientists previously believed. This challenges the long-held idea that the moon has been inactive for billions of years and raises new questions about how it evolved and how it relates to Earth. If these findings are confirmed, they could reshape our understanding of how the moon formed and provide valuable clues about the early solar system. Even more exciting, they might offer new hints about the conditions that could allow life to exist on other worlds. Beyond the mineral and magnetic findings, Chang'e 6 has also advanced the confirmation of water ice in the moon's South Pole region. While water ice has been detected before, the new data suggest larger and more reachable deposits than earlier studies indicated. Using high-precision spectrometers that track hydrogen levels, the mission pinpointed areas that strongly suggest substantial ice reserves. Water ice on the moon is vital for long-term human activity. It can supply drinking water and reduce the need to transport large amounts from Earth. Through electrolysis, it can also be separated into oxygen for breathing and hydrogen and oxygen for rocket fuel. This could allow the moon to function as a refueling point for missions traveling farther into the solar system. The economic impact of this is significant. Launching materials from Earth is extremely costly, especially due to the fuel required to escape Earth's gravity. If spacecraft can depart with minimal fuel and refill on the moon, deep space missions to Mars, asteroids, or the outer planets become far more practical. China's results support years of predictions and data indicating that permanently shadowed craters, with temperatures near -240 degrees Celsius, can preserve ice for billions of years. These deposits likely formed from ancient comet and asteroid impacts and then settled into cold traps across the region. The amount and placement of this ice will influence where future lunar bases are built. Areas with easy access to water will hold major strategic value, and China's detailed mapping provides an early advantage for planning upcoming operations and infrastructure. If you enjoyed this video, give it a like so YouTube can recommend it to even more people. Tap the hype button right below if you're watching on your phone. The discovery has drawn strong attention in the United States. NASA, which is moving forward with its Artemis missions, is now feeling increased pressure. Its goals include landing the first woman and the first person of color on the moon by the mid-2020s, building a long-term presence, and preparing for future missions to Mars. Artemis also includes the Lunar Gateway, a small station in lunar orbit, and the Artemis Base Camp near the South Pole for extended astronaut stays. More American leaders are beginning to see the moon as a strategic location, important for both science and national interests. The possibility of accessing resources like helium-3 and rare earth elements has turned the moon into a major point of economic and technological competition. With China's newest findings, the competition has become even more intense. There are also concerns about the strategic impact of lunar bases. The first nation to build permanent infrastructure on the moon will gain major advantages in operations, resources, and rule setting for future activity. This has led to discussions about increasing Artemis funding and strengthening international partnerships through the Artemis Accords, which more than 30 nations have joined. Concerns are rising in the US government about a potential lunar land rush. Although agreements such as the Outer Space Treaty of 1967 prevent countries from claiming ownership of the moon, the lack of strong enforcement creates uncertain conditions. As China moves ahead with its lunar goals, the United States is facing growing pressure to expand and secure its own activities on the lunar surface. The similarities between today's lunar competition and the Cold War space race are clear. But the differences matter even more. In the 1960s, the mission was symbolic, centered on placing a flag on the moon to showcase national strength. After the Apollo landings, attention faded, and the moon remained mostly untouched for decades. The current space race operates under new priorities. The moon is now viewed as a source of valuable resources, a place for major scientific progress, and a strategic position in cislunar space. These factors have turned it into a key arena of global competition. China's space program reflects a long-term plan supported by steady investment and coordination across government, military, and commercial sectors. This unified approach has allowed China to advance rapidly, achieving milestones in a short period of time. The United States and its partners are responding through cooperation. The Artemis Accords outline principles for transparent and peaceful exploration, including sharing scientific data, protecting historic sites, and allowing resource extraction within international law. More than 30 nations have joined, aiming to shape norms for future lunar activity. China has taken a different path, forming partnerships outside the Accords. Its collaboration with Russia to develop the International Lunar Research Station shows an effort to build an alternative framework. Several other countries have shown interest, creating two distinct groups pursuing lunar exploration. This divide raises concerns about coordination and communication. Without shared rules, missions could interfere with each other, or conflict over access to resources. There are no strong global systems for resolving disputes in space, adding to the risk. Some experts warn that tensions on Earth could extend to the moon, especially as countries develop technologies that could threaten satellites or lunar infrastructure. Others believe cooperation is still possible. Projects like the International Space Station show that nations can work together even with political differences. Joint scientific research on the moon might help build trust and improve communication. Both competition and cooperation will shape the future of lunar exploration. The moon has become a stage for major powers to pursue influence, with outcomes that reach far beyond its surface. Early leadership in lunar resources and infrastructure could define the future space economy, setting standards, building supply chains, and giving nations long-term advantages as humanity expands into space. The moon's economic potential has shifted from theory to active planning. Governments and private companies are developing models for extracting and using lunar resources, driven by discoveries such as accessible water ice and unique minerals. These materials are essential for electronics, vehicles, renewable energy systems, and advanced weapons. Although not truly rare, they are difficult and environmentally costly to extract on Earth. China currently controls most of the global supply, giving it significant influence in technology markets. Lunar deposits, formed in different conditions than Earth's, may be easier to process and could reduce dependence on terrestrial sources. Helium-3 is another major resource of interest. Deposited by the solar wind over billions of years, it could serve as a clean fuel for future fusion reactors. Fusion technology is still experimental, but if it becomes viable, helium-3 could provide immense energy. Mining it would require major investment and depends on advances in fusion, but several nations are preparing for that possibility. Water ice has immediate operational and economic value. It can support life, produce fuel, and become a tradable commodity in cislunar space. A system in which companies sell water to missions or stations could emerge, creating a new market in space. In situ resource utilization is key to lowering costs. Using local materials for construction, fuel production, or oxygen extraction reduces reliance on Earth's supply lines. Mastering these technologies will give nations and companies significant advantages as the lunar economy expands. China's findings help make economic planning more precise by identifying resource locations and concentrations. This gives China an early lead in choosing base sites and designing extraction systems suited to local conditions. Private companies are responding with plans for mining operations, though most face steep financial and technical challenges. Legal uncertainty adds another layer of complexity. The Outer Space Treaty bans territorial claims but does not clearly address ownership of extracted resources. Some countries have passed laws allowing companies to claim what they mine, but the international consensus remains unclear. This ambiguity creates both opportunities and risks for future lunar industries. International focus on the Moon's south pole is driven by features that make it the most valuable region for long-term exploration. The area contains permanently shadowed regions, or PSRs, which never receive direct sunlight because of the Moon's small axial tilt. Next to these frozen craters are high points that receive nearly continuous sunlight. These peaks offer ideal locations for solar power, providing steady energy without the long darkness that affects most of the Moon. The combination of accessible ice and constant sunlight makes the South Pole the best candidate for future lunar bases. This is why major programs, including Artemis, Chang'e, and Luna, all target this region. The South Pole's terrain is rugged, with deep craters and sharp elevation changes. This creates challenges for landings and rover travel, but also presents diverse geological environments and resource possibilities. Data from the Chang'e 6 mission, including detailed imagery and maps, helps identify safe landing zones and plan future infrastructure. This information gives China a strong planning advantage. The scientific importance of the South Pole is also significant. Ice preserved in PSRs holds a record of ancient solar system conditions, offering clues about water distribution, asteroid impacts, and early planetary history. The region also supports astronomy, especially on the far side, where Earth's radio noise is blocked. Telescopes placed there could study early cosmic signals that cannot be observed from Earth. Competition for ideal sites at the South Pole is expected to grow. Only a small number of locations provide access to both sunlight and ice, along with safe terrain. This raises questions about how access should be managed. Options range from first come, first served, to coordinated international sharing or designating protected research zones. Clear global rules do not yet exist. The Artemis Accords propose safety zones to reduce interference, but specifics are still undefined. China and Russia's plans for their lunar base include separate approaches to managing territory. Without coordination, overlapping activities could create disputes as more missions enter the region. Economic projections for the lunar economy vary, but even cautious estimates place its future value in the hundreds of billions of dollars, while higher forecasts reach into the trillions. This growth is driven by expanding interest in lunar infrastructure, resource extraction, and new space-based industries. The first phase of development will focus on services. Launch and landing support, transport of cargo, and mission logistics will form the foundation as scientific and government activity increases. Companies such as SpaceX and Blue Origin are preparing reusable systems to reduce the cost of reaching the Moon. Resource extraction will follow as infrastructure improves. Water ice is expected to be the earliest commercial target because it can support life and be processed into fuel. Companies able to supply water or propellant in cislunar space could become key players. Manufacturing may also emerge as a major industry, as the Moon's low gravity and vacuum conditions support production techniques that are difficult on Earth. Energy production could become another important sector. Large solar power installations on the lunar surface may one day transmit energy to Earth, offering steady clean power if technical obstacles are resolved. Tourism may develop slowly, starting with expensive trips for a small number of customers. Growing infrastructure will increase demand for construction, communications, life support technology, and transportation. These activities will generate jobs on Earth and create new roles for workers supporting lunar operations. China's discoveries help drive this development by clarifying the location and scale of valuable resources, reducing uncertainty for investors and planners. The identification of Chang'e site adds scientific interest and possible commercial value depending on its future applications. Even modest uses could justify missions dedicated to collecting additional samples. Financial markets are responding as well. Space investment funds are emerging, and several aerospace companies have gone public. Venture capital is supporting startups focused on lunar technology, encouraged by long-term market potential. Governments are shaping policy frameworks for the lunar economy. The United States favors a model led by private companies with government oversight, while China uses a more centralized system that blends state, military, and commercial efforts. These differing approaches will influence how lunar industries grow and compete in the coming decades. Private companies are reshaping lunar exploration in ways that mark a major shift from the government-driven programs of the last century. Firms such as SpaceX, Blue Origin, Astrobotic, and Intuitive Machines are developing capabilities once limited to national space agencies, speeding up mission timelines and lowering costs. SpaceX plays a leading role. Its Falcon 9 rocket dominates commercial launches, and its Dragon spacecraft regularly carries astronauts and cargo to the International Space Station. The company's Starship system, designed to be fully reusable, aims to carry large crews and heavy equipment to the Moon and Mars. If successful, Starship could reduce launch costs dramatically and transport more than 100 tons to the lunar surface. NASA has selected a Starship variant as the lunar lander for Artemis, highlighting a new partnership model in which government programs rely on commercial systems. Blue Origin is developing the Blue Moon lander for cargo and crew missions, and emphasizes using lunar resources like water ice to support long-term operations. The company also proposes the Orbital Reef space station as part of a broader infrastructure network that supports lunar activity. Astrobotic and Intuitive Machines focus on lunar delivery services under NASA's Commercial Lunar Payload Services program. Their landers will transport scientific instruments, technology tests, and commercial payloads, creating a market similar to package delivery, but for the lunar surface. Other companies specialize in rovers, habitats, life support, power systems, communications, and manufacturing technologies suited to the Moon. Together, they form a growing industrial ecosystem that supplies tools and services required for sustained lunar operations. Commercial involvement drives innovation and competition, but it also introduces challenges. Companies must balance profit motives with safety, scientific goals, and environmental responsibility. Regulation remains limited, especially regarding activities on the lunar surface, creating both opportunities and risks. Governments are still developing policies to manage commercial expansion while supporting national interests. China is also expanding its commercial space sector. Its private companies operate under stronger government oversight but are increasingly contributing launch systems, satellites, and other technologies, influencing the pace and direction of China's lunar ambitions. The Moon remains a major scientific target, with many basic questions still unresolved despite decades of study. China's recent findings highlight how much remains unknown about the Moon's origin, evolution, and composition, opening new directions for research in planetary science. The leading explanation for the Moon's formation is the giant impact hypothesis, which suggests it formed from debris after a collision between early Earth and a large object. However, this theory struggles to explain why Earth and Moon rocks share such similar isotopic signatures. The discovery of changeasite may help refine these models. Its properties could reveal whether the Moon formed under different conditions or experienced geological phases that current theories do not account for. Magnetic anomalies detected by changeasite add another scientific puzzle. The Moon lacks a global magnetic field today, yet Apollo samples show it once had one. Understanding how strong and long-lasting this ancient field was is important for studying the Moon's interior and thermal evolution. The localized anomalies found by China may be remnants of that field or related to specific mineral deposits, requiring further mapping and possibly targeted sample return missions. Water ice on the Moon raises key questions as well. Scientists are studying how it formed and accumulated. Some may have arrived through comet impacts, while some could have formed through chemical reactions involving solar wind hydrogen. The isotopic signatures of lunar ice can help determine its sources. Permanently shadowed regions may also contain other volatile compounds, offering a record of the solar system's history. The Moon's geology provides a clear record of billions of years of impacts, volcanism, and tectonic activity. China's high-resolution mapping, especially of the far side, has revealed major differences between the Moon's two hemispheres, deepening questions about lunar evolution. The Moon also offers scientific advantages unavailable on Earth. Its stable surface preserves ancient geological processes, and the radio-quiet far side is ideal for astronomy. These factors make the Moon an important platform for studying both planetary science and the early universe. China's discoveries are renewing scientific interest and highlighting the importance of collaboration. Coordinated missions, shared data, and joint research could advance understanding while balancing scientific, economic, and strategic priorities. As lunar exploration accelerates, major ethical and legal questions are becoming increasingly urgent. Key issues involve ownership, environmental protection, equity, and long-term governance. The Outer Space Treaty of 1967 bans nations from claiming lunar territory, but does not clearly address whether extracted resources can be owned. The United States and Luxembourg allow companies to claim mined materials, while others argue this violates the treaty's intent and could create unfair advantages. China's ongoing lunar plans suggest it intends to use resources as well, yet there is still no global agreement on how extraction should be regulated. Environmental concerns are significant. The Moon preserves billions of years of geological history, and large-scale mining could destroy scientifically valuable areas. Permanently shadowed regions containing water ice and other volatiles are especially sensitive, storing information about the solar system's early history. Disturbing them could permanently erase this record. There are also worries about biological contamination from Earth microbes, which could interfere with scientific research. Cultural and historical preservation also matters. Apollo landing sites and other mission artifacts lack binding international protection. Industrial activity on the near side could even alter the moon's appearance from Earth, raising questions about humanity's shared cultural rights. Equity is another unresolved challenge. If lunar resources create major economic value, it is unclear who should benefit. The idea of treating the moon as the common heritage of mankind has been proposed, but the Moon Agreement supporting this framework has few signatories and little practical influence. Governance remains fragmented. No international authority exists to regulate lunar activity, allocate resources, or resolve disputes. Nations and companies currently set their own rules, increasing the risk of conflict. As private firms expand their role, questions arise about safety standards, liability, worker protections, and legal jurisdiction for future lunar settlements. These issues will grow more pressing as temporary missions evolve into lasting bases. Decisions made now will shape the ethical foundation of humanity's presence beyond Earth. Lunar exploration raises philosophical questions that go beyond technology and economics. For much of history, the moon has been a cultural and symbolic presence, influencing religion, art, science, and human identity. As it becomes a site for industry and settlement, our relationship with it shifts, prompting debate about what should be preserved and what may be changed. Some argue that parts of the moon should remain untouched because they hold historical and scientific value. Others believe that since the moon has no ecosystems or life, preservation is less compelling, and that its resources should be used to support human expansion. These discussions connect to broader questions about humanity's future. Some see becoming a multi-planetary species as a natural and necessary step that will inspire innovation and ensure long-term survival. Others argue that resources used for space exploration could be better invested in solving urgent problems on Earth, and warn that expanding into space may repeat past patterns of inequality and exploitation. Values will shape how humanity approaches the moon. Lunar development could be guided by cooperation, scientific curiosity, and shared benefits, or by national competition and resource claims. The choices made now will influence how humanity approaches Mars, asteroids, and other worlds. Competition between major powers reinforces these questions. China's discoveries have accelerated strategic rivalry, but they also highlight the potential for scientific collaboration. Whether nations compete or cooperate will shape the nature of the future space environment. The moon also raises questions about the meaning of discovery. Scientific findings reveal phenomena that have always existed, yet they change how humanity understands and interacts with the moon. This leads to debate over whether exploration is justified only by practical benefits, or whether knowledge itself has independent value. Humanity is approaching a moment when a permanent presence beyond Earth is possible. Decisions made today will determine not only how the moon is used, but what kind of spacefaring civilization humanity becomes. The story of China's lunar discoveries is ultimately a story about humanity at a crossroads. The technical achievements are impressive, the scientific findings are significant, and the economic and strategic implications are profound. But beneath all of these considerations lies a more fundamental question: what kind of future does humanity want to create? China's lunar discoveries have left the United States stunned, not because they were unexpected in principle, but because they have made the future arrive faster than anticipated. The race is on, the stakes are clear, and the outcome remains uncertain. What is certain is that the moon, long a symbol of distant dreams, has become the stage for humanity's next great adventure. The question now is not whether humanity will return to the moon, but how and what kind of future will be built there. If you enjoyed today's video, don't forget to hit like, subscribe, and turn on the notification bell so you won't miss our upcoming journeys. And if you like to see the cool things China has done, check out my video about China drilling to the bottom of the Mariana Trench, where China spent billions of dollars to get to this depth. Click on the tab that appears on the screen now. Enjoy! Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.